This is video 4.2.1, and the goal of this video is to just understand a couple of properties of these trig functions on the unit circle. So first of all, understanding the even and odd values of the trig functions. So even and odd, so looking down below, you'll see what it means for a function to be even and what it means for it to be odd. A function is even if you can plug in negative x, or the opposite of x, and get the same value as if you plugged in f of x, so just plugging in x. So f of negative x gives you the same value as f of x. A function is odd if you plug in negative x, but the actual answer becomes negative. So that's when you get f of negative x equals the opposite of f of x. So what does it matter for this case? Well, what's nice is the trig functions kind of have a lot of repeats in them, and so with that, some of them are even and some of them are odd functions. So let's take a picture of theta. It's just a random angle in the unit circle. Negative theta, of course, would be going downwards the same amount of degrees or radians. So these two angles, let's take a look at their sines and cosines. So if this theta has values x comma y, then the opposite of theta would have the same x value, because the triangle, notice, has the same x, the horizontal leg there, as the top triangle. Now the y, though, is positive above and negative below, so the y value switches to negative. What this tells me is that cosine is an even function, because cosine is the x value, and the x value stayed the same for theta or negative theta. And it doesn't matter where I drew theta, it would always be true in that way. So the cosine of an angle will always equal the cosine of the opposite of that angle. Now, since it's true for cosine, of course that means secant, its partner function, it's also going to have the similar relationship. Now, hopefully you're writing these different values down in your notes so you can reference them. But really, once you know the unit circle, you can retrieve these pretty simply by looking at some values on your unit circle. Now, what about the other functions? So notice that because y became negative y, that means sine is an odd function. And the sine of the opposite of theta will always equal the opposite of the sine of theta. It's kind of like that negative doesn't disappear. And of course, the cosecant will also work in the same way, because the cosecant is related to the sine. Now, tangent is about slope. Tangents will be a odd function, because if you take a look simply at the picture, the triangle above has a positive slope and the triangle below has a negative slope. They're still the same value, absolute value, but one's positive and one's negative. So they are also an odd function like sine. So these three, this is going to help us just find values a little bit quicker and kind of get rid of negatives a little bit sooner, so we don't have to work so hard when calculating values. So the cosine of negative pi over 4 will be the same as the cosine of pi over 4. So if I'm trying to find that value, I can use my triangle of pi over 4 and find my value of square root of 2 over 2 using my unit circle. So you should already have this value in your unit circle. Now, sine of negative pi over 4, that one's not in our unit circle yet, but because of this understanding of even and odd, I know that's going to be the negative of sine of pi over 4, which will in turn mean it'll be negative square root of 2 over 2. That should make sense because this is an angle that's in quadrant 4. Negative pi over 4 is in quadrant 4, and the sign will be negative down there. Now, the next thing you'll want to add to your notes are some helpful identities. The first identity is called the Pythagorean identity. This states the following, that sine squared of theta plus cosine squared of theta equals 1. Now let's take a look at why. If we draw a random triangle on the unit circle with a radius of 1, like you see here, and sides x and y, by Pythagorean theorem, x squared plus y squared equals 1. Well, we know the trig values are cosine is x, so cosine squared of theta plus sine squared of theta also has to equal 1 because of our definition of sine and cosine. Now sometimes this notation throws students off, the notation that says cosine squared of theta. This simply means that it's, it's not sine squared of theta. It simply means cosine of theta squared plus sine of theta squared. And the reason we put the square on the cosine is because we don't want people to think we're squaring the angle. We're squaring the cosine of the angle. We're squaring the function cosine. So we're squaring those two, adding them together, and they equal 1. That's what this notation means when we put the square on the actual cosine squared theta. That's what that means. But notice it takes a lot more writing. We have to put parentheses around things to write it this way. And so we don't usually write it this way. We write it this way because that's more of a proper way to write it. It's also simpler and less writing. So that's your first identity that you need to understand. Now what follows is two more identities with the Pythagorean identity. And they're simply manipulations, and they actually have to do with the quotient identities. So we'll look at why that works in class in a warm-up. So tangent squared of theta plus 1 will equal secant squared of theta. And that's true for every angle theta. And then the final one is 1 plus cotangent squared of theta equals cosecant squared of theta. These three identities you won't need to get memorized, but you'll want to become familiar with them and start recognizing when they pop up in different problems, because next chapter we're really going to get into identities. So if you have a strong understanding of these, it'll help you next chapter. The next identities are quotient and reciprocal identities, so add that to your title there. The reciprocal identities we'll start with first. We've already talked about them, but we're just going to make sure they're in a space on our paper. That cosecant is 1 over sine, secant is 1 over cosine, and cotangent is 1 over tangent. Now the next set of identities are the quotient identities. Because tangent of theta is y over x, and y is just sine, we can erase y and put sine there of theta. And of course x we can erase and put cosine of theta. This is your first quotient identity. Tangent of theta equals sine over cosine. Now, of course, that follows that cotangent is going to have a quotient identity as well. We can keep it in terms of cosecant and secant, or we can also write it as cosine over sine, since that's the reciprocal of tangent. So those are your quotient identities. Again, these don't need to be totally memorized, but you need to be very familiar and ready to work with these identities. So the more familiar you are, the faster all your problems will be. So here's your multiple choice and your free response question. It more follows what we did in class, so do your best to try and find these values. Take a quick note of the picture here. Each of these little marks, from mark to mark, it's a pi over 6. And then, of course, that means that 2 marks would be a pi over 3. So that is something that you'll want to use in order to help you find the cotangent of pi over 6 and the 6 trig values of the angle pi over 3. So do your best to give those answers in your assignment, and make sure you simplify and try to write them properly. Bring your stuff into class. If you're having trouble entering this on the Google form, at least bring your information into class and we'll make sure you got the right answer. So bring those questions in. We'll see you in class tomorrow.